Okay guys, welcome grade 8 students. We now move forward to our next lesson, which is about exterior angles. Okay, so exterior angles are found outside of a polygon. Okay, so what we're going to see here is the exterior angle theorem for polygons. So the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. So how do we do that? Okay, so for example right here, so let's use the pen and let's use a white ink. So let's say for example we have here a triangle. Let's say we have a very regular triangle, an equilateral triangle. So if it's an equilateral triangle, that means it has the same measurement of sides. And if it has the same measurement of sides, also it has the same measurement of angles. So that means this measures 60 degrees, 60 degrees, and 60 degrees. The sum of the interior angles for a triangle is 180 degrees. So 60 plus 60 plus 60 is 180 degrees. And each of the angle measurement is 60 degrees. Now, if you form an exterior angle outside of it, so what we have here is a line. Okay, so if that's a line and this is 60 degrees, then we can make a line that will continue here, or that would coincide there with the 60. So we have here 180 degrees minus 60 degrees. So that means the measurement of this exterior angle right here. So that's an exterior angle. Okay, so the measurement of that exterior angle is actually 120 degrees. Okay, so if you create another exterior angle right here for this angle, so that's also going to be 120 degrees, and also for here at this angle. So if you draw there, and that's also 120 degrees. So if you add 120 degrees, 120 degrees, and 120 degrees, you have three exterior angles right there. So you get 360 degrees. So that proves our theorem right there. So 360 degrees. Okay, so we have our first problem. Given pentagon trope on the figure above or here on the left. Okay, so find the number of sides and the triangles formed. Number 2, the sum of the interior and exterior angles. Number 3, the value of x and the value of x. Number 4, the individual interior angle measurements. Number 5, the individual exterior angle measurements. And number 6, the number of diagonals formed on pentagon trope. Okay guys, so given here pentagon trope, so given pentagon trope on the figure on the left, we want to find the number of sides and the number of triangles formed. So that's the first thing that we want to find. Second, we want to find the sum of the interior and the exterior angles. The third one is we want to find the value of x. The fourth one, we want to find the individual angle measurements of each of those interior angles. And then fifth, we want to find the individual exterior angle measurements of all of the exterior angles there. And the sixth one, we want to find the diagonals and the number of diagonals for pentagon trope. So how do we find that? Okay, so what we're going to do is first we want to find the number of sides. Okay, so that's very easy. Okay, so to find the number of sides, what we have to do is simply look at the figure. So that's a pentagon, so that has 5 sides. So number 2, how many triangles are formed? So we use the formula n minus 2. Okay, so what's our n? N is equal to 5. Okay, so we simply substitute 5 minus 2, then you get 3. So there are 3 triangles for all types of pentagons. Okay, so moving forward, okay, we have here number 3. We want to find the value of x. Okay, so just x. Okay, we want to just find the value of x. Okay, so how do we find the value of x? What we do here is we simply equate all of the interior angles here, all of the interior angles that we find here on this pentagon. So we have the first interior angle. What's our first interior angle? So that's x plus 10. And the second interior angle that we have is 2x minus 12. The third one is x plus 4. The fourth one is x over 2 plus 8. And the fifth one is 2x minus 1. Okay, so we have this equation right here. We have x plus 10 plus 2x minus 12 plus x plus 4 plus x over 2 plus 8 plus 2x minus 1. So what value do we equate these terms that we have here? So to solve for that value, what we have to do is we have to write the equation n minus 2 times 180. So what's the value of n? Okay, so we can write there as 5 because it's the number of sides. So 5 minus 2 times 180. And 5 minus 2 is simply 3. So that's 3 times 180. And 180 times 3, so that's 540. Okay, so that means we have to equate this entire terms here, the 5 terms that we have here, with 540, the measurement of the sum of the interior angles of the pentagon. So what's x plus 2x plus x plus 2x plus x over 2? So that's simply 13x over 2. So how did we get that? So x plus 2, so that's 3x, plus x, 4x, plus 2x, that's 6x, and 6x plus x over 2. So you can kind of like see x over 2 as kind of like, since we have here 6x, okay, so 6x over 1, so plus x over 2, then we can simply say that the 6x right here, we can transform that to 12x over 2. So that's going to be 12x over 2 plus 6x over 2. We can add that, then 12 plus 1 is simply 13. So that's 13x over 2 is equal to, what's that, 540. Okay, 540, so that's plus 10. It's going to be minus 10 here, and then minus, no, that's actually minus 12, so that's going to be plus 12, then plus 4, that's going to be minus 4, then minus 8, then plus 1. Okay, so that's going to be 13x over 2 is equal to, so we have here 540, then minus 10, then plus 12, then minus 4, then minus 8, then plus 1. So we get 531. Okay, so 13x over 2 is equal to 531. So to get the value of x, we simply multiply this entire equation right here with 2 over 13. So 531 times 2 over 13. The answer is 1062. Okay, so 1062 over 13. Okay, so let's write it here. Okay, so the value of x is actually 1062 over 13. Okay, so we're going to keep that as a fraction because when we substitute that, we want it to be the exact value. Okay, so in terms of substituting that value, so we want to find the specific angle measurements of each of the interior angles in the pentagon trope. So we do that by substituting the value x. So again, the value for x is equal to 1062 over 13. So we substitute that value to each of the angles. So we have angle T, so that's x plus 10, so you substitute 1062 over 13. So that's going to be 1062 over 13 plus 10. So the answer is going to be 1192 over 13, or that's simply 91.69 degrees if you want to make it as a decimal. Then for angle R, same process. So you substitute 1062 over 13 to 2x minus 12, and you get 1968 over 13. And if we divide that, we get 151.38 degrees. Then we also have x plus 4. So there, the value is 85.69 degrees. For angle P, we have 48.85 degrees. We're just simply substituting the values. Okay, for x over 2, if you want to substitute that, so that's going to be 1062 over 13 divided by 2. Okay, so that's how you substitute that. So that means you have to multiply 1062 over 13 times 2. Okay, so we have to multiply a bit because that's the reciprocal. Okay, and then plus 8, and you're going to get 48.85 degrees. And also we have 2x minus 1. You simply substitute 1062 over 14 there, and you get 2111 over 13, or 162.38 degrees. So these are our final answers, okay, the fraction ones, and also the ones that we turn into decimals, because we want an exact value per interior angle for angle T, R, O, P, and E. To measure the exterior angles, okay, so in measurement of the exterior angles, always remember that you see these two. So the property that they share is actually they are supplementary angles. Interior angle, an interior angle, and an exterior angle are supplementary angles. So that means if this is 2x minus 12, and we already solved for this value, okay, so the value for that is actually 1192 over 13. Okay, or 91.69 degrees. So that's the value of angle T there. So what we have to do is we have to minus that with 180 degrees. Okay, so 180 degrees minus 1192 over 13. So why again do we have to minus it to 180? It's because they are supplementary angles. So they're supplementary angles, and there, to get the measurement of this angle, to get the measurement of angle 2, you have to minus or subtract 180. You have to subtract 1192 over 13 from 180 to get the value of angle 2. And the value of that is 1148 all over 13, or 88.31 degrees. Okay, so if you keep repeating that, if you keep minusing or deducting or finding the difference between 180 and also their interior angle supplement, for angle 2 it's 1968 over 13, you will get 372 over 13, or 28.62 degrees. For angle 3 you get 94.31 degrees. For angle 4 we get 131.15 degrees, and for angle 5 we get 17.62 degrees. And if you add all of these, okay, if you add all of these 5 values, their exact values, you're going to get 4,680 over 13. Okay, so we want to prove that it is equal to 360, because it is said in the polygon exterior angle theorem that the sum of the measurements of all of the exterior angles in a polygon is actually 360 degrees. So by proving this one, okay, we can see that actually 4,680 over 13 is equal to 360 degrees, and that proves the polygon angle theorem. So there. So using algebra, we were able to prove the polygon exterior angle theorem, that the sum of the measurements of the exterior angles of a polygon is 360 degrees. So therefore, these are the measurements of angles 1, 2, 3, 4, and 5 respectively. Okay, so we move forward. So how do you find the number of diagonals for angle trope? So that's very easy. So we use the formula n. Okay, so let's use white. So we use the formula for finding the diagonals. Okay, so the formula for finding the diagonals is d is equal to n times n minus 3 all over 2. So what's the value of our n? N is equals to 5, so that's 5 times 5 minus 3 all over 2. So that's actually 5 minus 3 is 2. So 2 times 5 is 10, and 10 divided by 2 is equals to 5. Therefore, there are 5 diagonals in a pentagon. Okay, so that means that there are 5 diagonals. There are 5 diagonals in the pentagon. Okay, so a tip for solving these kinds of problems, if you see that they have fractions, try to make a table. Okay, try making a table, because it will make the solution or the process of solving for the exterior and interior angles per angle much more easier and much more organized. Okay, so we want to make it more organized, and The reason for that is it involves fractions. If it doesn't involve fractions, you can simply just substitute. But since it involves fractions, so fractions, the value of x is a fraction, we want to get the exact value. So that's why we try to use a table to make it more, or to make it more cleaner, to make it cleaner, or to make it organized or more organized. Okay, so that's about it. So we have here, okay, so we have here a summary of a table for the properties of a polygon. So we have here the number of sides for the second column, the number of triangles formed for the third column, so that's n minus 2, the sum of interior angles, so that's n minus 2 times 180, then the individual angle measurement. So we have one for the interior, that's the formula, and for the exterior, we also have the formula. And we also have the number of diagonals. Okay, so for this problem, we have, okay guys, so what we have here is a table of summary of different types of polygons, and we want to make a summary of their properties. So we have here the polygon, the freegon, the fourgon, the tetrachontagon, the octacontagon, the 132gon, and the myriagon. And then we also have the number of sides for the second column, the number of triangles formed for the third column, and also their formula. The fourth column is the sum of the interior angles and the formula. Then we also have for the fifth and sixth column the individual angle measurements for the interior and the formula, and the exterior and its formula. And lastly, we have the number of diagonals, n times n minus 3 all over 2. So if, for example, we have their freegon, so that's a triangle, so that's a polygon with 3 sides, so its number of sides is 3. The number of triangles formed there is n minus 2, so that's simply 1. The sum of the interior angles, simply substitute n. Okay, so n is 3 minus 2, so that's 1, and 1 times 180, that's 180 degrees. And then we get that interior angle, that's the individual angle measurement in the interior angle of the triangle. So that's n minus 2, so that's 3 minus 2 times 180 all over 3, and you get 60 degrees. And for the exterior angle, 360 all over 3, you get 120 degrees. And for the number of diagonals, you get the number of sides, which is 3, times the value of, again, of letter n, which is 3, minus 3 all over 2. So that's simply 0 over 2, and if you divide 0 and 2, you get 0. Okay, so there. So that's the summary for the trigon or the triangle. So you can also do that same recurring pattern or same way of solving for the fourgon, for the tetrachontagon, or for the 42gon, for the octacontagon, for the 80gon, and also for the 132gon, and also for the myriagon. Okay, so you can fill that table using simply your calculator, and you'll get these interesting properties for specific types of polygons. And what you can also notice is the interior and exterior angles, if you add them, they always equal to 180 degrees. As the interior angle gets bigger, the exterior angle gets smaller. Okay, so that's one thing that you can notice about the individual angle measurement for these types of polygons, because the interior and exterior angles are supplementary angles, or they form a linear pair.